Let's build a spot welder. I've took this bad boy from an old microwave oven, and this can be very useful. Rest in peace, kitchen appliance. Your guts will be used for a cool project. If you don't have a huge transformer like this one, casually waiting on your workshop floor to break your toes, are you even a maker? You see, this could input 220 volts here and output around 4000 volts on the other side.
What?
So be careful. 4000 volts, or as I like to call it, an instant hard reset. So don't touch it. But if we remove this secondary and replace it with only one loop of this very thick wire, instead of getting very high voltage, we get very low voltage but huge current. In that way, it's not that dangerous for us, and also a huge current could melt metal. And that's how I'm planning to make a spot welder. So let's check what we need. Banana for scale. Now you could make a crude spot welder with just the transformer and a simple push button. But that is not ideal nor efficient. I want to precisely control the timing of the spot weld. Unless you enjoy guessing the time and make your battery explode. I don't, so I'll use this. So guys, that's why we'll control the pulses using this, an Arduino microcontroller. I've also designed a cool PCB for this project, so you can download the Gerber files from below for free as always. The PCB file is free, but the fire extinguisher which you might need is not. By the way, this is the design right here in Altium. Right now I'm designing Altium. And remember, I've made these pads here and this exposed so I can add more solder so it could withstand more current. Here is the input from the 9 volts AC. I have the rectifier DC, and that's connected directly to the V-in pin of the Arduino. That's how we get our 5 volts DC. Now the schematic is quite simple. Remember, you can download it from below, and if you also want to try Altium, you can use the link below /electronoobs, and as you can see, you get a free 30 days trial without even giving your card and only your email, and you can test it out. It's a great software to make your PCBs. Right now I'm working on the same schematic, but I'm adding some extra parts, for example some temperature sensors, because I want to monitor the temperature of the transformer, the wires and everything that I have inside of the case, and that will be for a future update. So yeah, it was quite easy to design this in Altium. It's very fast. The board I think is 90 by 60, and yeah, download my Gerber files, which you can download from below, and then order the PCB. Okay, once you have downloaded the files, go to PCBWay.com and click the Code Now button, and then select the PCB size, the amount, and also the color. In my case, I've selected the black solder mask, which is my favorite. You save to cart, and on the next page upload the Gerber files and place the order. That's how easy it is to order from PCBWay. And if you also need some sort of enclosure for your project, which you will see that we will use, you can also check the rest of the services for 3D printing or metal engraving. The links are below. Okay, so now I have my PCBs. So let me tell you what we have on these boards. Okay, these are all the parts of the project. On the back, the PCB was designed with these exposed tracks, so we could add more solder, so it will withstand more current. Then this line here shows the separation between low voltage, 5 volts or 9 volts, and 220 volts AC. Never touch the PCB while connected to power. This side, safe, happy, 5 volts. This other side, hello darkness, my old friend. Know the difference. And the current will be controlled by this triac, the BTA 100. And this triac is so massive, it needs its own zip code and a permit from the local electrical grid. And the PCB also has an input for a foot pedal like this one right here, so we can control the pulse with our foot and have our hands free. By the way, I found this for only $3, otherwise I will be printing it. It also has these 2 potentiometers and 2 push buttons, so we can control the timing of the pulse and maybe some modes. Okay, let's first hack the transformer and then assemble the PCB. Okay, we need to remove the secondary winding. You will see that the transformer has a winding with some thicker wire and some thin wire. We need to remove the thin wire and have patience because this will take a few minutes. And by a few minutes I mean a solid half hour for you to question all your life decisions. To take out the winding we have 2 options. Break the wire or break the transformer. If you have a welder, you can do as in my case, just use an angle grinder, cut this weld here, open the transformer, get out the wire, and then you have to weld it back how it was. But if you don't have a welder, well, in that case you need a saw, cut the winding, make 2 holes or a few holes with a drill, and then use the hammer and take out all the wire. You will lose the wire, but in that case you will keep the transformer how it is. Now that I have it open, I'll later clean it. I'll try to first remove the primary, then the secondary, and put back the primary. Actually, I think I've done a mistake. Now, I thought that I would be able to remove the glue with some glue removal, but it's impossible to take it out. I mean, I do have the force to take this out, but the moment that I touch this with something that is hard, with metal or wood, I will take out the enamel from the transformer, as you can see here, so I'll have to fix this, and that will result into a short circuit. So I'll close back the transformer and just cut out this with the saw. Okay, now that it's welded back, hopefully it was not damaged, nor the core or the winding, hopefully. So I'll use my saw to cut the secondary and take it out. I've told you a few minutes. Yeah, it was like 15 minutes. Look how much copper. It's an entire chunk of copper. Look at this mess. And oh, my thumb. I've told you a few minutes. It took me like half an hour, maybe less than half an hour. Yeah, you have to use power tools. Actually, this metal drill bit was the best because I was pushing the wire inside and then drill it, push it and then drill it. And yeah, now it's clean. We can add our own wire. But first, let me clean my workshop and get some new gloves. Now that we have it clean, we'll make a loop, only one loop, using very thick wire. I'm using this wire here, just a small pause. Message for later is actually 2 loops, not just 1 loop, which is from a solar charger. It can withstand a lot of current. So as you can see, I've made only 1 loop with the wire and we can test the output. The thicker is the wire, the better. So now the transformer is ready, I'll just test it out and hopefully I haven't damaged it. And be careful. We can hear the typical 50 Hz humming and as you can see we have 1.74 volts. So it's working, it's not damaged and there is no short circuit. So job complete, this is exactly what we wanted, around 2 volts at the output. 2 volts is safely enough to leak, but please do not leak the transformer. Only 2 volts, but look how much current we can generate. Okay, now on the other side we need to prepare the PCB and the rest. First I will solder the high voltage part, meaning the triac, the high voltage capacitor and resistor, and the optocoupler. We use optocouplers to separate the high voltage from the low voltage of the Arduino. And by the way, I've also added a fuse. Okay, now let's solder the low voltage side and we start with the power input, and for that I have this, yet another transformer. We connect this transformer to the same input as the peak transformer, but this will only generate 9 volts, which will be connected here to this pad. Then we have a rectifier, a capacitor, and we have 9 volts DC, which we can then supply to the Arduino and regulate it to 5 volts. Okay, I soldered the connector for the pedal and the 9 volts input, the capacitor and the rectifier with the diode, also the buzzer and the pins for the Arduino. Let's also solder the potentiometer, button and the OLED display. Remember to fill this with solder. Because of the way I've designed the case, you will see, I've decided to place the buttons, the potentiometer and the screen with wires, have the PCB on the floor of the case and then connect them with wires directly onto the case. Okay, the PCB and the transformer are ready. It's time for the code. I've made the code quite simple. We have 4 functions. We read the potentiometers to know the values, we handle the buttons in case you push it, we check the pedal or the input from the button, and the display the results on the screen. And that's it. But during the check pedal, we run another function. So here is the check pedal function. We run execute sequence. Each time that you press it, we execute the sequence of making the weld. And in the sequence is very easy. If you are already armed the machine, we make a tone, very short tone. We make the pre-weld and then the weld, and that's it. Pretty easy. You see, some spot welders like this one here are using a burst of pulses, sometimes 4, 6 or even more. That would be good for DC, but this is AC we are working with, and that will result into some problems. The first problem is that we are working with an iron core of the transformer. This is not meant to work with high frequencies. 60, 50 Hz. If you're using very fast pulses, it will saturate the core. The second problem is that each pulse will hit the metal more and more and deeper. And for example, with batteries, that could damage the battery, and you don't want that. That's why a professional way to do this is using two pulses, a pre-weld and the welding pulse. That's why in the code I have first the pulse 1, which is the pre-weld. It will clean the area and eliminate any residue, and then the weld, which is the second pulse, the main weld. And then we make sure that the pedal is released, because otherwise it will keep adding pulses and pulses. That's why we make two pulses. If we want to precisely control the current that's passing through the wires, we need to implement a zero cross detection, because this is AC. Please check the triac control video where we control with Bluetooth a triac, and we have implemented the zero cross detection if you want to know more about that process. Okay, the code is uploaded, it's time to assemble everything. For the case I'm planning to use a combination of 3D printed parts that I've designed and you can download for below for free as always, some wood, screws, washers and some small parts as well. I'm always sharing everything that I do on this channel for free, so maybe you want to support me on Patreon or comment below. Your support will be for my electrical bill after testing this monster. Okay, for the 3D parts first I've made the handle. For the handle I first bought some very thick copper plates. I've cut them to size, drilled holes and also made some threads because we will add screw into this, and this will be the connector for the electrodes. Using the screw holes I've cut to size some other smaller plates of copper and screwed them in place here because this will hold the electrodes, and now we'll add two springs inside of this plastic support because this will keep the electrodes under pressure when you want to weld. As you can see, the wires will be connected here and this will have the electrodes, and as you can see, if I push it will make pressure because we have those springs there, and if I close this like this, we should have our handle, but it has something more. That surprise is that here, as you can see, we have space for one of these end stop switch. In that way, when we will push it, it will click it and activate the weld. It's the same as with the pedal in case that you want to just press and weld, press and weld. So instead of connecting the pedal, you will connect this push button, and just with the handle you can weld. There I have the push button in place, and this will be pushed by the electrode support. Okay, the handle is ready. Later we'll add some proper connectors for the wires to connect to this, and as electrodes I will use these copper rods that I bought for only 50 cents. They work great. For the main case I'm using these 3D printed parts for the perimeter. We add the screws onto the wood and into the plastic, so we make the walls, then we merge them together and we make the case. And for example, the screen, the potentiometers and the push buttons will go on this 3D printed part that will go on top of the top wood. That's how we make the control, and for the terminals from the transformer I'll use some screws in case that I want to change the handle. Okay, the case is almost assembled. I've also made the front part where the screen will go. So I'll place the PCB here connected to the screen and the potentiometers, and this bad boy here in the middle with some sort of insulation, and all the wires well connected so we don't have any short circuit. We don't want that, especially since this is made of wood. So please check the connections below on electrums.com if you want to make the same project. Following that schematic, you can make all the connections inside of the case. So let's just do that. Okay, first step, I have the input and the switch, and I've screwed in place the transformer on the bottom, and now I start adding a lot of heat shrinking tubes on all the cables so I have good insulation. I've connected everything with wire to the PCB, the screen, potentiometer and the push buttons, and I've also shortened the wires from the transformer and then add proper connectors, because this will go with screws to this connector and it will output on the top part. Okay, everything is connected. I just wanted to give it a quick test before I close the case. As you can see, the OLED screen shows the time. We can set the time of the weld, but if I click this simulates the pedal. It only beeps because it's not armed. I arm it, and now we can weld. Do you hear the humming of the transformer? And I can change the time to bigger. And this will be the maximum time. Okay. Hey guys, just a small pause here. The case is ready, but it's not welding well. Now I did make some tests before adding all this and it was welding well. Now the problem is for sure these screws. Now this is a bottleneck for me because they are not made of copper. I don't know what I was thinking. So they are introducing a lot of resistance and the current is not getting to weld the batteries. So what I'll do for now, I will order some copper screws or some copper connectors, but till then I will just connect these wires directly to the transformer inside. Okay guys, moment of truth. Everything is in place, main input and on-off switch here, high current output directly connected to the handle, input from the pedal or the switch. So I power it on. We can adjust the settings and we arm it. Okay, now for the real test, can it weld a nickel strip to the battery? And there you have it. That's pretty strong there. Here we have one of the welds. I've made a few. As you can see, it's pretty well connected. We just pull it. As you can see, I pull it quite hard and it won't break. So it's pretty much welded in place. And here we have the weld a little bit closer. So guys, I would say a pretty good job for a homemade spot welder, right? Now I'm not happy about the enclosure at all. I mean, wood, I'm not sure. I mean, I do remember that back in the days, all the high power gadgets were using wood case. I mean, the amplifiers, my pickup was made with wood. And yeah, now maybe not this kind of plywood, you should use treated wood, or maybe even better, use acrylic or metal and make sure that you shield it. I actually have connected ground from the cables to the transformer just to be sure. But yeah, maybe acrylic would be the better choice. Now there is a direct connection to the transformer, but I still have these connectors here, which I'm not sure that will conduct the current as well as copper. So maybe I should buy some different connectors. Still a bottleneck here. Here we have the electrodes, and when they wear out, you can just buy new ones or maybe just make them from some copper wire. At least I should give it a paint job. But yeah guys, finally the project is ready. I was a bit nervous that it won't work when I had a problem with the screws, but now I'm happy with the results. Remember, I'm sharing everything for free, the PCB, the code, the STL files and all the connections in the description below. So maybe consider supporting me on Patreon, or at least comment below or give me a like. That will push me on YouTube a lot. So thanks for that. And please don't melt your tools. See ya!